This video derives the derivative of the logarithm function using the first principles definition. Understanding this proof builds intuition for limits and prepares you for advanced calculus on exams. You'll learn to apply the limit definition, simplify using log properties, and use a key limit identity. We'll derive the derivative of log x from the first principle. First, apply the limit definition. Then use the log subtraction rule to combine terms. Substitute z equals h over x to reshape the limit. Finally, apply the standard limit that equals 1. Let's work through it on the diagram. What is the derivative of log x? The answer, 1 over x, looks simple. But where does it really come from? Most students memorize the result without ever seeing the proof. The derivation uses the limit definition, the log subtraction rule, and a clever substitution. Goal: derive the derivative of log x using the first principle. Step 1. The derivative from first principles uses the limit of a difference quotient. By definition, dy by dx equals the limit as h tends to 0 of f of x plus h minus f of x, all over h. Our function f of x is log x. Substitute log x to get the limit of log x plus h minus log x divided by h. Now combine the two log terms using the subtraction rule. Step 2. Use the log subtraction rule to merge the two log terms. The difference of logs becomes the log of the ratio, x plus h over x. Split the fraction. X plus h over x equals 1 plus h over x. So the derivative equals the limit of 1 over h times log of 1 plus h over x. Now make a substitution to convert this into a standard limit. Step 3. Let z equal h over x. As h tends to 0, z also tends to 0. Set z equals h over x, so h equals x times z. Then 1 over h becomes 1 over xz. The limit rewrites as 1 over xz times log of 1 plus z, as z tends to 0. Pull 1 over x outside the limit. What remains is log of 1 plus z over z. The remaining limit is a famous standard result. Step 4. The standard limit of log of 1 plus z over z, as z tends to 0, equals 1. This standard limit equals 1, so the derivative equals 1 over x times 1. The derivative of log x is 1 over x. Whenever you need a derivative from scratch, set up the limit of the difference quotient and simplify until a known limit appears. For log x, the key moves are the log subtraction rule, the substitution z equals h over x, and the standard 1. The derivative of log x is 1 over x. A clean, elegant result, fully proven from first principles.